Hey, welcome to Nested Loops, session 9 of the Design Patterns Explained book. We're picking up chapter 11, Abstract Factory Pattern, and Don will pick it up, so I'll let him take over.
All right, so in this chapter, we're going to continue talking about patterns with the abstract factory pattern, which is used to create families of objects. We'll look at an example that helps us derive the factory pattern, present key features, and then talk about very briefly how it relates to the CAD/CAM problem. So first, our intention with the abstract factory pattern is to coordinate the instantiation of objects. And according to the Gang of Four, it's really to create families of related or dependent objects without specifying their concrete classes. So in other words, we don't want to say class name.new. We want to have something else do that for us. So sometimes several objects need to be instantiated in a coordinated fashion. For example, when dealing with user interfaces, the system might need to use one set of objects to work on one operating system and another to set a set of objects to work on a different operating system. And the abstract factory pattern ensures that the system always gets the correct objects for the appropriate situation. So that's kind of our motivating example here, is to select device drivers according to the machine capacity. So suppose we've been given a task of designing a computer system to display and print shapes from a database. The type of resolution used to display and print the shapes depends on the computer the system is running on, or specifically the speed of the CPU and amount of memory that's available. So we need a system that will be careful about how much demand it's placing on that computer. So the challenge here is differentiating between low resolution drivers on a less capable machine and high resolution drivers on a more capable machine. So we kind of have a table here that says for a low capacity machine, we want to use a low resolution display driver, or LRDD, and low resolution print driver, LRPD. But in a high capacity one, we want to use high resolution display driver and high resolution print driver. And this kind of brings a point to about the pattern in general, which is to define families based on an underlying or unifying concept. So you want to group these classes together into these families based on these concepts. In our case, low resolution or high resolution. And that's pretty much what it says here. So if our goal then is to create some objects that were made from these certain classes and decide the appropriate time in which to use them, the obvious first alternative solution is to use a switch. So in this case, I might see that we can use a variable resolution, and if it's low, then our draw method would use the low resolution display driver. If it's high, it uses the high resolution display driver, and the same thing in print. But as the author says, there are problems with this solution, specifically tight coupling, which is that if we change a rule in the resolution, or for example, let's say we need to add a middle value that it wouldn't be high or low resolution. Now we need to change it in both methods, and they're unrelated places. Then there's weak cohesion because we're giving do draw and do print two unrelated assignments. They're not just drawing and printing now, they're also deciding which driver to use. So that can be a problem. And like he says, it might not be a problem right this second. Like, this is a simple way to do it, just using a switch statement. But then down the road, when you're maintaining this code, there's going to be more places to change and more complexity. So since we're talking about, patterns and objects, the next solution is to use inheritance. And this seems okay at first. So in this case, our AP control, it's going to have attributes that say which driver is going to use for displaying and printing. But we're just going to make two subclasses: low resolution app control and high resolution app control. And their constructors, the corresponding constructors, would create the drivers of the appropriate resolutions and assign them to these attributes: display driver and print driver. So that sounds okay too, except Now we're going to have a bunch of different versions of our app, basically, which is what he talks about here, is a combinatorial explosion. For each different family and each new family we get in the future, we must create a new concrete class that's a new version of app control. So for example, if you have a new requirement for a medium capacity application, one that uses a low resolution print driver and a high resolution display driver, we would need to make a new class to handle that case. If you needed one to handle the opposite, high resolution print driver and low resolution display driver, you need yet another class. So you're going to have a whole bunch of different variations of app control. And obviously, if you're getting into more complex stuff, you're going to quickly run into problems. There's also unclear meaning. The resulting classes do not help clarify what's going on. I've specialized each class to a particular special case. And if I want my code to be easier to maintain in the future, I need to strive to make it as clear as possible what's going on. Then I do not have to spend a lot of time trying to relearn what the section of code is trying to do. And last, need to favor aggregation. I'm not exactly sure what this rule is. Favor aggregation over inheritance.
That's one of the generic design patterns suggestions. If you have the choice of inheriting, well, basically, when you want this additional or new behavior, you have a choice of inheriting or containing the object and delegating to it. So this is aggregate rather than inherit. And if you remember earlier, he was talking about the use of aggregation in commonplace versus how I think the Game of 4 used it, or something like that, how they vary. And so the saying is, a variation of saying is not aggregation, but the other word. Basically, have an object rather than inherit from it. It's basically, I forgot what the other word was. There's another word that replaces the word aggregation with a different word, but
Composition.
Composition, yes, that's the one.
Well, so he gets into the third alternative then, which is to replace switches with abstraction. And he says that in his experience, he's found switches often indicate an opportunity for abstraction. In this case, obviously our low resolution, high resolution display drivers are both display drivers, and the other two are both print drivers. So a really easy abstraction is just to have a display driver base class and subclasses for each of the different resolutions. Same for print driver. And he points out, and he'll get to this later, that this is conceptually that they are the same because they may not actually derive from the same class. But we won't worry about that right now. That's where the adapter pattern could come in later. So this is, I know he's kind of giving an alternative here. One thing I was kind of bothered by, though, in this alternative is that it's not a full example until later. And still, there's it's not exactly a full example, which you'll see. But he still kind of demonstrates how this would work, is that if you had separate classes for each one, then your doDraw and doPrint methods would just have to call the driver that was already assigned. But this is also how the code would have looked in alternative 2 if you had been assigning the attributes and the controller. So I don't think the code example in this section is it's really too great, but anyway. The reason we're defining the objects this way is that now the app control class is much simpler to understand. It's not really concerned about the type of driver that's used. As you can see here. So yeah, this gets down to what I was saying is the question is how do we create these objects, and then later it's going to be how do we decide which ones to actually create in app control. But anyway, instead of having app control do it, the abstract factory pattern uses another class. In this case, we're going to call it res factory or resolution factory, and it will control the creation of the display driver and print driver classes. And the interaction would look something like this, where the app control class, it asks the res factory class for a display driver. The res factory goes out and creates the appropriate one, in this case, the low resolution display driver, returns it to the app control. And then now the app control can call that driver directly. It probably would, like we just saw, save it in some sort of an attribute and then call methods on it. And same thing for the print driver. So the res factory's responsibility is the actual instantiation of these classes. And he says that the factory is responsible and cohesive. From the app control's point of view, things are now pretty simple. It lets the res factory worry about keeping track of which drivers to use. And he says that he's still faced with writing code to do the tracking, and he's decomposed the problem according to responsibility. So yeah, this part of this is just shifting the responsibility from the class that's going to be doing the work and the one that's going to be instantiating the objects. Okay, so there's one thing he points out is that the res factory itself may also use switches. But you can avoid that. And again, this whole like use of switches and decision making on which class to actually instantiate, we'll get to it later, but it gets kind of confusing here. But he says basically just that the res factory only cares about giving the appropriate display driver and print driver, the one that's being asked for. And this is his first kind of attempt at splitting that out, is to have two different classes. One that returns only low resolution display driver or print driver, and one that returns only high resolution display driver and print driver. And when you look at the code example here, yeah, it's just clear what each one's doing. The low res factory just returns the new LRDD and the new LRPD, depending on which one's being asked for. And the high res factory does the opposite. And I'm just actually going to jump down to where he says, I'm going to go back up in a second, but this kind of was my problem with the way he's showing the implementation, is that it kind of, you have to go through everything to see the complete example. I can't find where he says it, but he says basically that you would pass to app control the either low res factory or high res factory. But that still doesn't help you with the decision of which one is being used. And also it doesn't help you solve the problem of what if you have a low resolution factory that you need, now you need another factory. So yeah, this is kind of the complete example of what this would look like, is that the app control class would be given a res factory object that's either going to be a low res factory or high res factory. And then whenever in the constructor, whenever app control would call each of these to determine which display driver or print driver it gets, it would return the appropriate one. And then now app control can call that display driver directly without having to ever specify its class specifically, which is what this is all about, is not having the actual class name in app control. So it's just taking that decision out of app control, sort of. But again, you have to specify the correct low res or high res factory in this example, which still means that you have to make a decision on what you need when you create app control, which is a little weird. Anyway, going back up to like the core concepts of this. So, the key concepts for abstract factory strategy is to find what varies and encapsulate it. And in the design, we see that the choice of which driver object to use was varying, so we encapsulated it in the res factory instead of in the app control. To favor aggression, aggregation over inheritance. So we put this variation in a separate object res factory and have app control use it, as opposed to having two separate app control objects. That was what we saw before when using just a plain inherited solution that we had the problem, and this solves it. Then you design to interfaces, not to implementations. So app control knows how to ask res factory to instantiate drivers. It doesn't know or care how it's actually doing it. That, again, we don't see the full code example here of him calling the res factory, but I'm assuming in the constructor of app control, that's when it's going to call the appropriate, or call the factory that was supplied, call the get display driver or get print driver methods. It doesn't care, which actual classes are being, like class names are being used. It just relies on the factory to do that work. That's the core concepts in this. And again, here's our full example. So yeah, how this works again is that app control is given either a low res factory or a high res factory object, and then it asks that object for the appropriate drivers. And again, it doesn't really say how you decide, though, which one to supply app control. I guess you have to make that decision on your own. And to me, it still has a lot of the same problems, even though again, this pattern's a good pattern. I just think the way it's presented here is like a little bit confusing, because we don't go back to how we actually decide which one to use.
Yeah.
Yeah.
I mean, in practice, you end up having a res factory.
Exactly. And if you need, again, he's tying the low resolution display and print drivers to one class again, the low res factory, right? And both the high ones to the high res factory. So if you need something in the middle, you end up with having to make a third class, a third factory class anyway.
Well, I think that the point, and I guess if you're expressing confusion, the point is app control no longer needs to know or decide.
Yes, yes.
And I was going to wait until after the field notes, and I still think I will. When I look at this implementation of a couple principles leads us to this design. So I want to wait till after the field notes, but I'm just saying, and I think the real key, I mean, he shows that back the principles, aggregation over inheritance and that kind of thing.
Mm-hmm.
That's true. That's generally true. What am I saying? The cool thing is if you understand the principles, you understand why and how. Okay. We'll pick this back up after field notes.
Yeah, because he mentions some ways to do this at the end, right? But just pointing out there that we're still missing this piece of information.
Yeah. So we'll just say in this case, in practicality, you'd have another factory give you the res factory, which you would move. How do I know which res factory to get? Well, someone has to know, but we put another object for the same reason we put these in another object.
Right. Yeah, that's like factory, like you said.
And then it becomes very J2EE where you have factories returning factories of other factories. And then you don't get the code for an hour later.
Okay, but through this whole example, we've assumed that, back up, that, you can see here that the LRDD and the HRDD were both inheriting from the display driver class. When he originally laid out the inheritance example, he mentioned that they're conceptually derived, but not necessarily directly derived from the same classes. And that's what he gets into down here, is he says these pairs do not necessarily derive from the same classes. So for example, your high resolution and low resolution classes, they may not be related at all. But that's where we can bring in another pattern, the adapter pattern that we've seen before, to solve that. So in this case, our low-res factory and high-res factory are going to be returning our low-res display driver or low-res print driver, for example, that are derived directly from our print driver and display driver classes we had before, but maybe they are just adapters for other more complex classes. Like here we have the LRDDs not actually related to anything else. Same thing for HRDD. There might be no relation at all. So by using both the abstract factory pattern and the adapter pattern, we can still make it work. I think it actually becomes more useful then when you have this situation. Because you really don't want to know these details, right? Like you really don't care. In the app control class, you don't care about these details. The factory just does all this for you. So again, these interactions get kind of complex, but it works. Like he says, it's essentially the same as before. The only difference is that the factory object instantiates objects from classes that are adapters, that are going to adapt the objects that we started with. So by combining the adapter pattern with the abstract factory pattern in this way, I can treat these conceptually similar objects as if they were siblings, even if they are not. Does that make sense to everybody? Kind of.
Yes.
Yeah. Yeah.
Yeah.
That's a resounding yeah.
You can talk.
I heard more yes than people. So.
Yes. Yes. Do you hear me?
Yeah.
All right. So the one thing that you're saying, like at some point, the decision is supposed to be made, right?
Yes.
With a low, high res and whatnot. But it can be said about the printing versus the display, right? So the decision also needs to be made. I think that the point of that is that instead of having those decisions made in this code, you delegate up to somebody else, some external thing. And the external thing is either a configuration or a user input, right? You might have like a list of instructions that say, draw this, draw a circle on a low display printer, and draw a circle, low display, you know. Like you have to think about how all of this would come about, right? If this was like an Adobe Illustrator file that would get parsed, it would tell you the file itself. When you hit print, it will say, "Oh, print to what? To display, you know, or to the printer," and then it would give the correct, you know, the correct factory.
Yeah, I just find it interesting that, like, if you look back at the my bookmark not working. Okay, if you look back at the original example that he gives, he's using a switch because he needs to decide which one to use, right? He's switching on resolution, but we never actually see that brought back into any of these examples. It's like you said, he's making the decision go somewhere else, not in this code, right? It's somewhere above. And he does mention, like Forrest said in the field notes, that there are ways to make this decision, whether you use config files or whatever you use. But it's just interesting to me that this was the core problem that inspired the example and how we would solve it, and we never go back to looking at this decision again. But yeah, you're right. It does have, the decision has to be made somewhere, number one, and number two, the most important thing about this is abstracting out the instantiation of the objects themselves, and that we don't want to. It's more about this problem of the weak cohesion to me, not doing unrelated things on different methods, or even in the app control class at all.
Right. Yeah, because you know, again, it goes to single responsibility and all that kind of stuff. You know, this class was not just doing previously the drawing, the interacting with the load dryer, with the print or display. It was doing all the jobs, right?
Yes.
And say, okay, now we moved the decision of, like in later example, even like you would have an adapter pattern. Instead of being in the one single class for everything, now you have adapter pattern for every single thing. Whether it's a low, high resolution, or display, or printer, again, move to someplace else. And now this class is very, very simple. I mean, like, it knows you either do A or B, and nothing else. And all the other decisions are moved to other classes. And then yet again, all the decision about which one to instantiate is completely moved out of all of this code. So if you, let's say, imagine you have before you had display and printer, and then maybe you'll have holographic is the next one, right? You will have to add more switches in the first example.
Yes.
And now you only have to add
A new factory.
a new factory.
Yeah. Yeah. I think that also comes down to this. Although I agree that still the factory is way better than this, right? Than having two separate actual implementations. But it's similar, right? It's still a constructor that instantiates the appropriate ones.
Yeah.
Yeah, but it's just
functionality has not changed.
Yes, exactly. I think he even says that later, but let me go back up to where we were. But yeah, good points. Okay, so yeah, here was our big example using both the adapter and abstract factory patterns. Okay, so just again revisiting the roles of each of the objects. The client object, in this case app control, it just knows who to ask for the objects it needs. Whereas the abstract factory class specifies which objects can be instantiated by defining a method for each of the different types of objects. And then it actually creates them whenever you call those methods, obviously. And then yeah, each concrete factory is using the specific, is picking the specific classes to return. So okay, so talking about using it in the real world, which I think actually this example was sort of real world, but in the example that I just showed, implemented the abstract factory by having one concrete class per potential situation. In that case, I had two situations, low resolution and high resolution. In practice, the number of cases can be very large and can grow combinatorially with each new variable, that is, each new family member. For example, it might be that the family of objects relates to each customer in an e-commerce system. That is, each family of objects represents the choices a particular customer has made. In this case, having concrete class for each family would not work at all. A better solution would be to have one class to create all the families. There would still be a method relating to each family member, but the decision on which particular object to create would be handled by a switch. The question becomes, how do you know which option each customer wants? That is, what should be the value of the switch variable? And of course, that question was there all along. And this is what we talked about, Diego, is the abstract factory did not eliminate the need. Instead, it tells us what to do. So there's still a need to make these decisions. So yeah, it says to put the option in an object that's responsible for creating the used objects, and to keep this separate from the objects that are actually using the objects. It says to separate the use of objects from the construction of objects, basically. So okay, so then the issues in the pattern are as follows. Which case do I have? How do I manage this information? Where do I put the construction logic? So in the original problem we looked at, which case do I have? The original solution, app control knew this. But with the abstract factory solution, a configuration file saying which concrete factory object to create would answer this question. This is what we just talked about, is that this is not in the code example, but something will decide which abstract factory or which concrete factory class to provide to app control. How I manage the information. Originally, it was all in app control. But now each concrete object knew which objects it was to create, each concrete factory object, that is. And where do I put the construction logic? Used to all be in app control. Now it's in each of the concrete factory objects. Okay, and in the e-commerce solution, managing the information, that is, which customer do I have, or rather, which family do I have, is a little more complicated, but we can handle it by passing the customer ID to the factory and letting it resolve the issue. So this is kind of even getting into a more complicated thing of let's actually let the factory decide which class is going to return, which to me actually sounds a little bit better. That you maybe specify some information, then let the concrete factory class decide which class to return, instead of having lots of different concrete factories that you decide using some external process. But anyway, the factory could look at a configuration file or database, or it could even look at a cookie. I think that, with what we do with making web apps, this makes a lot more sense than having a whole bunch of different concrete factories that are different combinations of like low resolution, high resolution, for example. It seems to me like having one factory class make the decision based on additional inputs or additional information makes a little more sense. To me, maybe would have been a little better example. Just because it's very clear here that the decision, that there's some sort of basis for the decision. But in the previous example, it's like we're relying on some outside process we don't talk about to supply the factory. But yeah, like he says, are we back to switches now? If we're making these kinds of decisions, and the answer is yes. We're still using switches to decide things, but switches aren't bad. It's only bad when they're coupled together, like when one variable is the switch for, or the switch variable for many switches, which is kind of what we had before with the resolution variable at the very beginning. But in any event, now it's well isolated with the abstract factory solution. So then the last little note is about the naming. So why is it called abstract factory? And you might think at first that it's because the factory is implemented as an abstract class, but it's actually called the abstract factory because the thing that's intended to the things that's intended to build are themselves being defined by abstractions. So it has to do with, this actually goes back to like the adapter as well, is whatever you're returning or deciding to instantiate, they need to have some sort of a common base, usually. They need to be defined themselves by abstractions. That's why it's the abstract factory, not because we have multiple concrete factories that share an abstract factory base class. So he's just making that distinction. Okay, and so then now the field notes that Forrest was mentioning earlier. Deciding which factory object is needed is really the same as determining which family of objects to use. So in the preceding driver problem, we had one family for low resolution, another for high resolution. So the question is, how do I know which set I want? In a case like this, it's most likely that a configuration file will tell me. I can then write a few lines of code that instantiate the proper factory based on this configuration information. Like you said, we're back to a switch, right? We're going to look at a value in a config file outside of app control somewhere. We're going to read the value in the if statement and then instantiate the factory we need. So we're still kind of back to the switch, but not really. So yeah, just reviewing then the key features. The intent is to have a family set of objects for particular clients. The problem is that the family of related objects need to be instantiated. The solution is to coordinate the creation of families of objects and give a way to take the rules of how to perform the instantiation out of the client object that's used to create those objects. So the different participants and collaborators, the abstract factory, it defines the interface for how to create each member of the family objects required. That would be like to create the drawer, create the printer, print driver, or draw driver. And then typically each family is created by having its own unique concrete factory class, which is where we grouped the low or high resolution drivers. Okay, the consequences of the pattern, it isolates the rules of which object to use from the logic of how to use the objects. And to implement, you define an abstract class that specifies which objects to be made. That would be the methods on the abstract factory. And then you implement a concrete factory class for each family. You can also use files or tables to accomplish the same thing. So for example, you instead of having separate concrete classes, you would have like maybe a single factory that decides based on some sort of external information which class to instantiate. But either way, the main thing is to isolate the rules of which objects to use from the actual using of the objects. And yeah, here's kind of an example of using basically the same thing, but with the e-commerce context. So you can see from this example, we still have two different concrete factories that return different products based on which factory is being used. So it's a design that simplifies, hides implementation, and makes the system more maintainable. The client object does not know which particular concrete implementations of the server objects it has because the factory object has the responsibility to create them, not the client object. And it doesn't even know which particular factory it uses because that's specified as an abstract factory object. So something outside of the client is making that decision. Again, all the same points I guess we've been talking about. So the abstract factory pattern affords us a new kind of decomposition by responsibility. So those divisions are who's using the particular objects, which is the app control, or above it's the client, and who's deciding is the abstract factory and the concrete factory classes that extend it. Okay, and then just some more examples is what you might, like, again, what he said at the very beginning was that you have to define which families you need and group objects together in some sort of unifying way. So he's just giving some examples here of why you might split them up. Maybe you have different operating systems, different performance guidelines, different versions of applications, different traits for users of the application, different sets of locale-dependent resources such as dialogues, date formats. And after you've identified the family's members for each family, you must decide how you're going to implement each case. That is each family. And the examples above, we did this by defining an abstract class that specified which family member types could be instantiated. And for each family, we derived a class from the abstract class, or a concrete factory, that would instantiate the family members. Another variation is to use config files. So sometimes you have families of objects, but you don't want to control their instantiation with different derived classes. This is exactly what we've been talking about. So instead, you might use a switch based on the information in the config file to decide what the correct object is. And I believe, I don't think he says it necessarily here, that you wouldn't need an abstract factory in that case. You could just have a single factory that makes those decisions. You wouldn't have the need for multiple concrete factory classes in this case. But yeah, this again, what I was saying at the very beginning was that the actual decision of which one to use is the thing that was removed from the further examples until we talk at the end here. So further variation is using the class in Java. So using Java's class, if you're in Java or C#, you can instantiate the correct object based on the names. For example, a field could contain the value LRDD to indicate an object of the class LRDD is needed. And then you may not even have to store the full class name as long as you have a well-defined convention. And what this is really getting into, we see a lot in Ruby, is like metaprogramming, right? Which has ups and downs. Like there's good things and bad things. One thing people criticize about this is that it's not fully greppable. If you're using things like strings to determine the class name to instantiate, instead of specifying the full class name, that could get a little bit confusing. And some languages, like I don't know about Java, maybe somebody else can answer this. I don't know how much the compiler could keep things from going wrong in things like compiled languages or bytecode languages like these. It seems like that would be an issue.
If you put in the wrong value, it crashes just like that.
Well, yeah, you crash at runtime, right? So the compiler then couldn't decide if it's going to crash because it doesn't know what the string is going to be. But yeah, this is something we see a lot though in Ruby, is this kind of metaprogramming thing. But okay, adapters in the abstract factory. In the real world projects, members of different families do not always have a common parent. This is where he showed us that you could use an adapter. So even if you have complex, unrelated classes that you want to instantiate, you can use an adapter to create a common base for them. And finally, he very briefly relates the abstract factory pattern to the CAD-CAM problem, and basically says that the families he would use for the CAD-CAM problem would be V1 features and V2 features. So you could have a factory for creating a concrete factory for creating only V1 features from the CAD-CAM problem, and a separate concrete factory for only V2. And then you would specify, you would instantiate that appropriate factory and pass it to the CAD-CAM application, so it would know which features to instantiate using the factories, which makes sense. I don't have a reference to that directly, but if everyone remembers, there were 2 versions. That's really all you need to know there.
All right, so now we hit the end of notes. My quick barometer on this is, Andrew, you understand this pattern? Are you slightly confused?
So confused.
Suddenly confused. I can try to put it in my own words and then see how it goes. Where I would want to use a factory is if I notice that I have a class that calls a set of methods, and if I use that, it gets out of control quickly, because then if I add new implementations, I have to go within each of those methods and update the switch case. And if I wanted to add another method within that class, I would also have to add it. What helps with factory is that I can pull out essentially what the switches are doing into something that can provide the concrete implementation of a rule, but without having to state those implementations each time I want to use it.
If you look at the original code, when you said print, there was like a secondary step, the switches.
The switches, yeah.
Where we're going to say high res or low res.
Right, right.
and then you give the correct driver, and then you do the stuff, right?
Yeah. Because if that class called 1,000 methods, and if I were to update the resolution to ultra high resolution, now I have to add an ultra high resolution to each of those switch cases for those 1,000 methods called within that class.
Yeah. So there were like two different types of abstraction at play. In this case, we had a display and print abstraction, but also you have like this sub abstraction and like high-res, low-res. So I think like that's as I was reading, the reason why it's called abstract factory is not because it has an abstract class, but it's because the thing you build are based upon abstraction. Are factories of abstractions. So I think that's like something like
that's a good way of thinking.
You have to keep in mind. Like when you have code that has switch cases or make decisions that are not related to what the code is supposed to do.
Yeah.
They kind of need to pick something, right? Like for example, I don't know if I can talk about like, you know, you have multiple payment gateways, right? You have CyberSource,
Bitcoin.
well, yeah. If there was a payment gateway, right?
IOUs,
right? And they're all different. And like when you say do payment, you have to say, oh, which one, right?
Right.
So that you move all those things out of the way.
It makes it easier to maintain the class as well because it's like, oh, you know, charge, right? Have a method charge, have a method refund, and we just call upon the right factory. Sure that when you do it, you know, the refund user, you know, $12,000, and it's easier. And then like say, oh, I need to make sure I'm using, you know, this payment method, or this payment engine, right? Yeah, I see a lot of use to it. So parameter-wise, I think this is a great section to learn. Factories are abstract factories, which is cool to think of because if I'm thinking of it correctly, it's kind of like a factory of interfaces, right?
Yes.
It's like I know I have this interface, and it depends on so many different concrete ones, but I don't have to think of those concrete implementations. All I know is just that I want this kind of interface for this scenario. So I know exactly, like going to that factory, I just say, do this, and they'll figure out all that it needs to do to get those things.
Like the way I see it is like almost all patterns. They try to move if-else statements, style, logic, to a more prescriptive configuration style, right? Actually, like, none of those, like especially when the if-else statement are used to take other object that are external that your current object needs to interact with. Like, so we've seen it with almost anything. Like the adapter is when you want like a common interface from something else. Like you have those two different APIs, they all have different names. So you have your object needs to interact with something else, right? Something external. And this pattern like kind of makes it so that you don't care about knowing which one it is. You have a common interface. Exactly. In this case, again, you want to print and you want to display, but you have to interact with drivers. But again, you don't want to care about which driver. You just want to print. So you want to, get the right driver and just delegate to something else that decision. And almost all the patterns have is very, they're designed to interfaces so that you don't care what object you're using. You say bar, big bar. And something else is kind of like force actually not the correct word. I'm saying restrictive, but it's not restrictive. Declarative, is that?
Declarative.
Huh?
Hold on. Yeah, no, yeah, you wanted that declarative kind of style.
Yeah. So like pretty much like something else outside of all of this makes all the decision, and the object they just know, you know, send this command and good stuff is gonna happen.
Yeah. So a couple things. It's the better you understand these, the more you realize they're all applying the same sort of things. So he starts in the beginning talking about switches. So a switch and or ifs, if they are sprinkled around, is a typical smell that, for object-oriented language, it really calls for polymorphism. Anytime you see switch, 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 you should replace that with, polymorphism, which goes back to that single interface that all these guys share. So now you just call the one thing and it knows what to do. And that's, I think, in my mind, one of the biggest strengths of object-oriented programming and polymorphism is now the client code just, in the case here, app control, I don't care what kind of driver it is, I just call print on it, right? And so that's that interface. That's the, and when you see, again, a single switch is fine, two switches can be fine, but once you have several switches that are all sort of pseudo-related, that's your smell. Oh, I probably need an abstraction here that I can call the single interface. So there's a saying that goes along the lines of all problems in software can be solved with an initial level of indirection. And so you can sort of see we move the switches up so they can be in one place, which also fits in with the dry principle. Don't repeat yourself. By eliminating this duplication, you do that with the level of indirection. You push it up. So then, now if you know that you should move it up, the question is, where do you move it to? And that's really where and I like the word he used, decomposition by responsibility. That's basically saying single responsibility principle. Where do we move it to? Well, what are our concerns? Well, one guy makes stuff. That's a concern. Another guy uses stuff. So obviously we push up the switch into the guy who makes it. Though arguably he made an example of like operating systems. An operating system, typically it will detect your driver. Oh, I have VGA driver, so low res. Oh, I have a 4K driver, so I'll do high res. And so you may have something where if it has to determine in real time, complicated, a high-res driver, low-res printer, that arguably becomes another object. So then you have another thing that creates these abstract factories in that case. And that's something I think is very typical in operating systems where they auto-probe the hardware, or maybe even read config files. I mean, in the old days, you set the config files. In the new days, hardware software is smart enough to determine for you. So yes, polymorphism, don't repeat yourself, single responsibility principle. If you look at those as kind of driving philosophies, you naturally, I think, come to this kind of code conclusion, if that makes any sense. I'm trying to get for a deeper thing where if you just reason about a couple of things that you know to be good things, you end up here automatically, and then you understand both the pattern and how to implement it a little better.
Yeah, I think that's what he did here too, is just to show, hey, here's your red flag that you have cases, switch statements for which class you're instantiating and using. So, you clearly need to move to something better from this. So then you go to, okay, we're going to use inheritance. And okay, can we use inheritance in a smarter way? Because this also has problems. So yeah.
Yeah. All right. Now we can hit the question. Some of which I think we answered already.
Okay. So Although switches can be a reasonable solution to a problem that requires choosing amongst alternatives, it can cause problems for the driver problem discussed in this chapter. What were the problems? And I'll answer this one is that there was tight coupling and weak cohesion. And what might a switch indicate the need for? We just kind of talked about as polymorphism or some moving of that that decision outside of the class that was originally using it. Number 2, why is it called abstract factory? And it's not necessarily because you have multiple factories. It's because the factories are creating objects that are defined based on abstraction. Or they have a common interface, I guess is the other way to say it. Number 3, what are the 3 key strategies used in abstract factory? I think he actually said those, yeah. To find what varies and encapsulate it, favor aggregation over inheritance, and to design to interfaces, not to implementations. Okay, in this pattern, there are 2 types of factories, abstract and concrete. What the abstract factory does is to provide the basic interface or the list of methods that will correspond to each family. Like it'll be a name for each family of objects that's required. And the concrete factory will actually implement the code that instantiates the appropriate class from that family for each family. So you kind of need both if you're going to do the abstract factory pattern. If you only had one factory and you didn't have separate concrete factories, then you could have one class have both things because you would only have one set of methods. But yeah. So what are the consequences of the abstract factory pattern? And I think he also had that. Yeah, that you've isolated the rules of which objects use. The rules of which objects to use from the logic of how to use those objects. That was the consequence.
Then a good consequence, but
yes.
always at the risk of more code and level of indirection. So there's no free lunch. You get cleaner code, but now you have to read more files.
Okay, so then the Gang of Four says that the intent of the abstract factory pattern is to provide an interface for creating families of related or dependent objects without specifying their concrete classes. What this means is that you're not going to directly use the class name or like classname.new in the object that's actually using the class or calling the class. Easy example here is our printing example. All it does is ask the factory for the appropriate object. It doesn't ever specify the concrete class that it's using. In fact, the way it's implemented, it doesn't even know which class it's getting back. It just knows that class has a common interface with other classes in the same family.
Yeah.
Okay, opinions and applications. Why do you think the Gang of Four called it the abstract factory? And is it an appropriate name for what it's doing? Why or why not? Yeah, I think it's an appropriate name. I'm still not super clear on what the author says here is that it's not called abstract because there are multiple factories. It's called abstract because it's returning abstract things.
Things that are themselves abstractions.
Yeah, and to me, my exposure more for factories is mainly used in testing. Like for example, the factory girl gem, which is an easy way to delegate the creation of test objects. So when I've used it, it's never been the differentiating between multiple classes. It's more like I need some sort of a helper to create the test object for me. I don't want to have that in the test code because that would be that'd be too much complexity for the test code itself. So instead, we use factories. I guess, huh?
Sorry, I personally think a better name would have actually been abstraction factory.
Yeah.
Yeah.
Or something that involves family. Because the next question, too, is why do you need this when you have a family of objects? So I would think a family is a more appropriate, or something related to
Sure.
family of things.
Because like abstract, you have something called abstract class, and the way you implement it is through an abstract class, and it's like it's kind of overloading and confusing to me. If it was abstraction factory, I would understand that it doesn't refer to the way it looks in the code. In a different language, it'll be different.
Yeah.
Yeah, I guess what I'm thinking is, how do I decide whether I'm using just a regular factory or an abstract factory? Is it when I start returning different classes from the same method name, depending on situation, or is it when I have multiple concrete factories? At which point does it stop being just a regular factory that just returns objects that have been instantiated and start being an abstract factory? I'm not really sure.
Well, the factory, right? Pretty much.
The gang of four name for what you consider a normal factory is in fact like factory method.
Mm-hmm. Okay.
Which actually comes off of a factory. So it is confusing. You're using one thing to create objects, and arguably the benefit of a factory method is that it's cleaner, right? You can always call the constructor with all the parameters, but again, if you push that off and I say, hey, give me a factory.checking account, factory.savings account, factory.large margin account, right? I could do account.new, lots of parameters, or I can call the parameter. So the idea of the factory, I think, is a generic thing, is related to what the gang of four calls factory method, which of course tends to lift off an object known as a factory. So factory girl is more from that than from abstract factory.
But then there's a question here is, what if I have factory girl class that I've defined multiple methods that could be considered also families, that maybe they're still instantiating the same class, like an object of the same class, but in a different way or with different other classes attached to it, right? Like maybe one method is creating let's just say a user that doesn't have any products that they bought, but another one is creating a user that maybe bought 5 products. Is that now abstract?
No,
or not?
I think that's factory. Factory.
It's still factory, even though it's returning different families of. Yeah.
If it's returning same object with different parameters, that's factory. Factory method. Which again is exactly how factory girl works. Hey, I want to
exactly. Yeah.
Well, actually, that's technically not.
Yeah,
yes, I'm more with 3 subscriptions, 2 subscriptions, no subscriptions. That's all factory method. Make it easy for me to do these things that are otherwise detailed configuration and put it somewhere else.
Well, using some of our terminology, then, what if it's a individual versus admin versus some other type of user? There's sort of other classes.
Yeah, that one is a little closer because for us, 4 subclasses for the different kinds of users.
Yes.
Which maybe we shouldn't have, because I don't know. I don't know if we did that abstraction right.
Yeah. So I just was pointing out, I guess, like it doesn't become an abstract factory until the classes you're returning or the objects you're returning derive from a common abstract class.
I think
basically.
I think it becomes an abstract factory when you have more than one thing, more than one inheritance tree. Because you have display and you have printer, right? As opposed to 67 different kinds of displays.
Yeah.
And you could argue to only have one of each, but because you have 2 different types of things that are related, that's where the abstract factory.
All right, I just realized you're way over, but the last question, how do you know when to use it? Like we said, if you see like switch statements or if statements that are instantiating different classes based on different situations, and it's clear that those classes are somewhat interchangeable or have some sort of commonality, then you might consider using abstract factory pattern.
All right. Well, that's good. Thank you for doing that. Next one is part 4, putting all the patterns together. Thinking in patterns should be interesting. Chapter 12 is how do experts design? I'm wondering if we can ask Sam if he's willing to present.
I won't be able to. I'm sorry.
Okay. Anyone else want to before we?
I do.
Oh, okay. Cool. I'm just going to take this one. I'm taking a quick glance at how long this chapter is. Oh, it's pretty short. Okay. We'll do 12. Hopefully we have good discussions. I don't know that we want to try to do 2. Looking forward to 13. Yeah, 13 definitely looks long. All right, we'll just do 12, and it might run short. So we'll have Andrew in 2 weeks. Thank you for listening, participating, watching Nested Loops. Have a good day.